This time, we're supposed to find the total resistance of the circuit at each position of the switch. I have like two switches connected together. These two switches make one switch. This dashed line means that they are connected together. Now, what I'm going to do, I'm going to find total resistance, R total, for the first position. This one stands for the first position. This symbol represents ohm meter. I'm interested how many ohms I'm going to have between these 2 points. Now, if I'm going to have switch at the first position, my current is going to go by resistor R1, R5, R6, R3, and we'll get back to this point. So my R total for position 1 is going to be R1 plus R5 plus R6 plus R3. All these resistors are in series. Now plug in the values. R1 is equal 1 kilo. Remember, anytime you are going to see just kilo, and this is going to be value of your resistor, this automatically means ohms, kilo ohms. Sometimes on the diagrams, instead of kilo ohms, you are going to see kilo. This is done in order to save the space. So I have 1 kilo plus R5, which is equal to 5 kilo, of course, ohms, plus R6, which is equal 2 kilo ohms, plus R3, which is equal 3 kilo. 1 plus 5 is 6, plus 2 is 8, plus 3 kilo ohms is 11 kilo ohms. So total resistance of my circuit when the switch is at the position 1 is going to be equal 11 kilo ohms. Let's take a look at this circuit one more time. And at this moment, the switch is at second position, position 2. Let's take a look how current is going to flow. The current is going to start going from this point and we'll go to R2, we'll go to R5, we'll go to R6, and we'll go to R4. So total resistance at position 2 is going to be equal R2 plus R5, R2 plus R5 plus R6 plus R4 equals 2 kilo plus 5 kilo plus 2 kilo plus 4 kilo. And one more time, remember, anytime we have kilo, this automatically means ohms if we talk in terms of resistance. 2 plus 5 is 7, plus 2 is 9, plus 4 is 13 kilo ohms. Total resistance of my circuit when the switch is at the position 2 is equal 13 kilo ohms.